Hi there, welcome to this video. In this video, I'm going to show you guys a very typical word problem that will require us to apply our knowledge of finding integrals. Okay, so go ahead, pause the video, and try to understand the context of this problem. All right, welcome back. So, right now, what's given to us, the v is my velocity, right? And the t is time. Okay, so the expression I have over here, that is my velocity. All right. Now, what they are interested in is displacement. Right. They want us to find the displacement, which is expressed in s. Right. So they want us to find an expression for the displacement in terms of time. However, I'm going to highlight this. And I think you guys should do the same during the exam or test, whatever. Given that s is equal to 4 when t is equal to 0. All right, so that's the relationship. So t is equal to 0, that's a fancy way of saying at the beginning, right? T is equal to 0, that means at the beginning, or initially, right? So when t is equal to 0, my displacement is 4. So, what is the relationship between my displacement and velocity? What is the relationship? I hope your answer is, if I differentiate my displacement with respect to time, then I will get my velocity, right? Another way of saying that would be, if I integrate my velocity, I will get my displacement. Does that make sense? Right? So all this time, what we have been doing is, I know s of t, and if I can find the derivative of s, that will give me my v of t. Right? So now we are going to go in the opposite direction. Right? Opposite. So which means I need to find the integral of my v of t. And that's what we're going to do now. All right, so let me use a different color. Okay, so my v of t is this. So I'm going to find the indefinite integral of v of t plus 6t. The whole thing with respect to t, right? Put your parentheses, just good habit. So this is equal to parentheses. So the parentheses don't really matter. I can kind of cut them up in half. Plus integrate 6t. And in fact, I can also put the 6 to the front, correct? You can move the 6 to the front, t dt. Alright? Now, just be careful. So what do I differentiate to get e to the power of negative 3t? It will be e to the power of negative 3t, right? But if I differentiate e to the power of negative 3t, so let's say if y is equal to e to the power of negative 3t, so the stuff I'm doing right now, you should do that on scrap paper, okay? Don't show this. This is not the workings that you want to show people. This is scrap workings. If I differentiate this, I get e to the power of negative 3t, but I also have to differentiate the negative 3t. That will give me a negative 3. Right, so I'll get this byproduct if my answer is this. So which means I need to take care of it by having a negative 1 over 3. Right, so that will take care of the negative 3. All right. Plus, so in this part, second part, this is what do I differentiate to get t squared? The 6 is still there. Now, I'm gonna put down the 6 there, and then I'll give myself a bit more space. This is gonna be t squared, right? If I differentiate t squared, I get 2. So I need to take care of that. How do I do that? By having a half in the front, right? Plus c. So the 2 and the 6, that they get cancelled out. I will get, so this is my s of t. This is my s of t is equal to the integral of my v of t. Right? So all of this, they're all s of t. So s of t is equal to negative 1/3 e to the power of negative 3t plus 3t squared plus c. So this is the indefinite integral, right? Where my c could be any constant. But right now, we are almost done. We're only halfway done because there's this highlighted information that we did not use. We haven't used that yet, right? So s is equal to 4 when t is equal to 0. So which means s of 0 equal to, so all of my t becomes 0 now, plus c, right? The c is still there, and this is equal to 4. That is equal to 4. Make sense? Because my displacement is 4 when t is equal to 0. So now e to the power of, so negative 3 times 0 gives me 0, but e to the power of 0 gives me 0. Give me 1. So I'll get negative 1/3. This whole thing becomes 1. This whole thing becomes 0. So negative 1/3 plus c is equal to 4. So my c is equal to 4 plus 1/3. That will be 13 over 3. Okay? So now, let me try to squeeze in a little bit more space. So my final answer, because right now they want us to express s. They want us to express the displacement in terms of t. My final answer, I'm going to write that in black. I'm going to zoom in a little bit to get a bit more space. All right. So my s of t is equal to negative 1/3 e to the power of negative 3t plus 3t squared plus 13 over 3. This is my final answer for my displacement. Okay? So we knew how to find indefinite integrals, and now all we have to do, and when we were finding indefinite integrals, the c is always kind of just leave it there, right? Some of you guys don't even write the c. Please make sure you do. It's a good habit to do that, right? Because the c, technically the c should be there, right? So without the c, it is actually not very precise, not very accurate. Okay? So now when we are when we apply integrals to a context, in this case, this is physics, right? Velocity, displacement. We can actually, given some extra information, which is this, the extra information we have here is this, we can actually find the value of c. And with that, we can actually come up with the actual definite integral, right? The definite integral. All right, I'll see you guys in the next video. Hope you guys find this video helpful. Bye-bye.